As a medical student, I did neurophysiology research. And on the basis of that neurophysiology research, I was going to secure my exemption from the draft, the doctor's draft. When I went for my interview to be a research associate, the man I was supposed to work with wasn't on my interview list. And I called him at the lunch break, and he said, "Oh, I've been meaning to call you. I'm leaving." And in fact, he went to Pittsburgh. His name was Shanes, a very classic figure in the mechanisms of action of local anesthetics, which is what I did for my MD thesis. So here I was, trying to get a place at the NIH and not having anything to do, and Bob Berliner was the director of the intramural research, and he was handling the interviewees on that particular day. And he said to me that there's some funny program over at St. Elizabeth's Hospital where they do something with nerve, and maybe I could go over there and interview with them, and they might have a place for me. And I did. That's where I met Joel Elkes for the first time, and Nino Selmaragi, and they accepted me to come back at the end of my first year of residency in internal medicine. I did an internship in medicine and a first year of residency in internal medicine. When I went to the NIH to work at St. Elizabeth's, it was simply to establish a little bit of independent research record so that I could compete for being chief resident in medicine at Barnes Hospital, which as a student was the height of my aspirations. And there was Joel Elkes sitting behind what I thought was the world's largest desk, smoking what seemed to be the world's smallest pipe, and he interviewed me, and it was, as typical Joel, he was fascinated by what I had done as a medical student and fascinated by what we could do with it, and because he had started with myelin diffraction patterns. So he was really interested in peripheral nerve, which is all I had ever worked on. I was accepted into the program as a research associate starting July '62. Initially I was going to work on reserpine and look at how reserpine caused sedated behavior in animals by using macroelectrodes and EEG. But by then it had been clear from the work of Costa and Brody that reserpine was able to deplete catecholamines from the brain, and nobody knew what catecholamines in the brain did, so microiontophoresis seemed like the ideal way to go in there and spritz it on and see what it would do to the firing patterns.
Now, was Costa down at St. E's then?
No, he was in the Heart Institute.
Okay.
But shortly after I started with him, he and I met at some seminar and struck up a conversation, and he started coming over 2 and 3 days a week, and most of the pharmacology that I learned from Mimo during that interval of time. The work went well, and we were able to make a lot of headway into understanding the actions of norepinephrine in the olfactory bulb and in the hypothalamus. And we did some of the first recordings asking what dopamine would do to cells in the caudate nucleus. As a result of that, I had a lead article in Science with Selmaragi and an annual review, a pharmacology paper with Selmaragi and Costa. And it seemed to me that it was really...
Somebody was telling me.
It's kind of a niche here that nobody
Right.
seems to be in. So and it was a great time to be at the NIH because Jacques Lewinsky was there, Leslie Iverson was there, Dick Wertman and Saul Snyder were all there. And so the young kid seminars were truly exciting things, and we all were working on the same sets of problems from different dimensions. So it was really an exceptional time, although not ever having such an exceptional time, you don't understand how exceptional that it really was. So I went about my other guiding light, Oliver Lowry and Ed Dempsey, and they both recommended that I go to Yale to learn histochemistry with the electron microscope, because the question became not so much what does norepinephrine do, but where is the norepinephrine so they can do those things. And it was just on the cusp when the Swedes were doing fluorescence histochemistry. Mm-hmm. So we thought the electron microscope would be a much better way to see the norepinephrine fiber. So I started this odyssey of trying to make the gains in brain through staying germane to what I wanted to do. And that's how I got to Yale. Electrophysiology is a pretty slow thing, so if you do all-night experiments 3 days a week, you've got two more days you can do something with. So I went over to the NIH main campus and learned sort of elemental electron microscopy procedures from a very classic electron microscopist, Keith Richardson. And he was willing to take me under his wing and teach me the manual skills required to take a huge sheet of glass and break it up into ultramicrotome knives. July '64, I applied for a special mental health fellowship and was able to go with a rather ample fellowship stipend.
So you arrived in New Haven.
Arrived in New Haven, and almost the first week I was working in the lab of a man named Russell Barnett. Daniel Friedman called me. Somehow he had heard of what I was doing, and he invited journal clubs that he and Nick Jarman did. And he and Nick had just written their pharmacological reviews paper on hallucinogenic drugs and the serotonin system.
Right.
And what did I know about the serotonin system, and could you spritz that, and all these kinds of things. That was a different level of intellectual discussion, because this was now psychiatry people that I was dealing with, as opposed to people who were more or less basics neuropharmacologists.
Mm-hmm.
I very much enjoyed that conversation, but I had this particular focus on trying to document electron-dense reaction products for norepinephrine, and that took a lot of time too. It went fairly well, but middle of the first year, this technology of autoradiography with the electron microscope emerged. At the NIH and Julie Axelrod's lab, Lincoln Potter and Julie Axelrod had been able to show that if they injected animals with tritiated norepinephrine and then fixed the pineal glands, that they could see where the radioactive norepinephrine was accumulated, and then with the grains you could identify exactly which were the norepinephrine accumulating fibers. And Leslie Iverson and Jacques had done the same thing for the central nervous system. So, very fortunate moment, George Agajanian came back from the Army, and having worked as a medical student with Danny, he and I teamed up in Russ Barnett's lab. I went off to McGill for a long week to learn autoradiography. We came back, did the first experiments, and lo and behold, we were able to see norepinephrine fibers in the brain with autoradiography.